Okay, we're going to get started in a couple minutes. For those of you who have already handed in your textbook rental form, good job. If you haven't, you're welcome to bring it up after class today, or please get it to one of the TAs on duty over in the EDL, and they'll get that entered into our database to let us know who's all caught up on that. Now, a lot of questions have been brought up about where do I get the book. It's right on where you saw the instructions to print out the forms and everything underneath the course welcome part of the section. The link is right there. It's a PDF file. You don't need a code to access it. You click on it, you can download it, and you can start reading it. I wouldn't print it just yet because either tonight or tomorrow, hopefully tomorrow at the latest, we'll have the finalized version that has chapters 6 and 7 included there. I also have looked into what it costs to get it printed. There's a company called Lulu, they're owned by Amazon basically, and they'll print it for you for $14.82 or something like that, plus the shipping. If you get the slow shipping, it's another $4, I think. So for $18 more, you can have a printed copy sent to you, and I think it takes a week or two. And you can print it out locally in Kinko's and things like that, probably for on the order of $20 to $25. And that's up to you. It's an electronic copy that you're sort of paying for access to, but you're allowed to have it printed. And if the people at Kinko's give you some slack about printing copyrighted materials, the copyright page at the front of the book, you can point to them. It says you're allowed to make one printed copy. So you're welcome to do that. When I've been asking around in the various sections, it sounded like about 2/3 of everybody was planning to just read it on their computer or their tablet or their Nook or whatever. So that part is up to you, but if you want to print it, you can, and it's still going to end up being considerably cheaper than it was last year. Last year, the book for this class cost about $45, if my memory's right. When you add the $25 plus the printing costs, it'll be no worse than what it was last year, but you also get the electronic copy this year. So, if you have any questions about the details on that, you can come in. A question? Well, that's a good deal. At One, up over here in the basement of the library, prints it for $7.50-ish, something to that effect. So, double-sided printing? Okay, it's a smaller size page, but sounds like the best deal I've seen so far. So, you can get it as you'd like, and if you have questions about how to follow through on that, please let me know. I'll be posting instructions. If you want to buy it online from that company I just mentioned, I'll be posting instructions on the website as soon as they're finalized. So, let's go ahead and get started. If you haven't gotten your clicker set up, now's a good time. If you are in this main lecture room, channel 65 is what you should be logging into. If you are in our remote classroom, channel 51. And we'll get to a couple questions on that in a second. So, this is our first time doing it even as a test in the other room. We had some problems in the other room last class. Today, you guys in this main room will hopefully have a little bit of experience. And if you haven't bought your clicker yet, today is the day you start missing out on points. Okay? I think I said earlier that it's 3 points per lecture. It's actually 3 points per week. So if you don't have it today, you're missing 1.5 points, okay, out of 1,000. So I shouldn't say it like that. I should say it like it's a free 0.1 points out of 100 on your final grade, right? You do the clickers and you get questions right. Throughout the whole semester, you can get about 4.5 points out of 100. That's a big deal. If you decide not to buy the clicker and you just wing it the whole semester, your grade's going to be hurt by 4.5 points out of 100. That'll easily bring you from an A- down to a B or a B+. So you can do the math. Okay, last class we talked quite a bit about let me hit the lights here. We talked quite a bit about the background info, I'll call it, of engineering. We hopefully got across the point that this class isn't really about building hovercrafts. If you're a computer science person or if you're an electrical engineer, you might wonder, well, geez, isn't that a kind of a mechanical thing? And there's some truth to that. But the emphasis isn't really on the fact that it is a hovercraft class. We try to focus on these other things. It's about engineering design. It's about teamwork, good study skills, all of those other things. And we've talked about that quite a bit, not only in the first 2 lectures, but also in your first skills lab. So what we're going to get to today is the actual hovercraft stuff. But some brief reminders, first of all. Read the book. Your first homework assignment is due tonight. You don't even have to pay for it to do this first assignment, all right? Just so I'm clear. You don't need a code or anything to download that file and open it. The first reading quiz is due tonight, essentially at midnight, 11:59 p.m. In fact, if you hand it in at midnight, we're not going to grade it. The system will allow you to upload your answers, but we're not going to grade them. It was too complicated to set a deadline different for every section, so we're doing it this way. The TAs are just going to look at what time you submitted it, and they don't have to grade so much if you got it in late. So just get it in on time. 11:59, that's probably about the time you guys start studying, right? All right. This week, it's very important that you go to your skills lab, preferably to the right skills lab. We had a couple of people go to the incorrect skills labs. We're going to try to actually introduce you to your teammates. Your next week's assignment you are going to be doing with teammates, so you're going to need to make sure you know who they are. Question back here? It's supposed to take the best grade, but my initial looking at it makes me wonder whether it's actually doing that or an average. I haven't followed through on that. So by the time everything gets sorted out, it'll be your best grade. Okay. So if you don't get if you don't get a perfect grade the first time you take it, it's in your interest to try it again. Another question. Okay. Question was, if you're in the Monday skills labs, and someone else brought this up before class. If you're in the Monday skills labs, what should you do, especially about meeting your teammates, right? Well, first of all, I'll get to in a second. Well, might as well do it now. Everybody can check out who's on their team by logging into the CatMe system, okay? Now that you've done this, now that you've done those surveys, and we've had our chance to massage all the teams and do all that stuff, you should be able to log in. It'll tell you who your teammates are and what their emails are. I recommend, even if you are in the Monday sections that don't meet until next Monday, I recommend emailing each other just to introduce yourselves, and ideally you'll actually be able to get together and meet with them. You can't meet with them after this class, likely. You're not going to arrange it that quickly, but I recommend doing that. Now, I know that the deadline for the team charter is next Wednesday, and that'll give the Monday sections only 2 days to do it. I'm going to talk with Dr. Volstead, and we might actually extend that by a couple of days, but we'll see I want to talk with her before we make that official. So until you hear otherwise, it's still due Wednesday, even if your section's on Monday. Any other questions about that stuff? Okay, so please try to get the skills lab stuff straightened out. If you recently switched sections, you might encounter a problem when you show up in skills lab and your TA doesn't have you on any of the teams. Make sure that they get, or you can contact me directly, make sure that they let me know that we have to work that issue out. There are people who switch sections between the time when we made our printouts of our class lists and when you're showing up to the skills labs, and we're discovering that some people are not listed when they should be. We had them in a different section, essentially. Okay, and finally, your student contract and your syllabus quiz, this electronic certification, that is also due tonight at midnight. Please get that taken care of. Let's see, I already talked about the team charter. Skills lab assignments are always due at 11:59, the night before your skills lab is, and again, the TAs just won't grade them if they're not handed in on time. I try to make it clear when I give the assignment on the website down below, if the different sections have different due dates, I spell it out, what day of the week it is and what time of the day. Please take a look at that so you can not be confused about the due dates of things. You'll always have 1 week, that's basically how it's working, 1 week between when you talk about it in Skills Lab and when it's actually going to be due. Right? But the website actually has the date and time, so you should be able to sort that out. Please get into the habit, really, of dealing with these reading quizzes every week. We're going to have them probably for the first 2/3 of the semester, where you'll be reading one thing or another as we go along. Questions somewhere over here? Go ahead.
So for the Monday
The Mondays, if you have Skills Lab on Monday, that will be, your assignment will be due on the following Monday. Right. So for the first week, you guys basically have 2 weeks to do the assignment.
Right, but since we missed
Correct.
week 2 assignment.
Are you sure about, sure it says it's due next week? Okay. I have to look at that. That might be a mistake on my part. So the question was, when are the Mondays due? They will be due a week after you have it due. Now, the assignment 1 is due next Monday. Assignment 2, they're both due on that Monday? That's a mistake. Assignment 2 should be due 1 week later. Yeah, I tried to make sure I didn't screw up, but I won't I won't guarantee that I didn't. All right, I will look at that. I think I verbally clarified what the rule would be, though. And it's on videotape, so you can prove it if you have to. Any other questions? Okay, you'll get into the routine. Obviously, there's a lot of assignments in this class. Some of them are fairly short and easy, but the reading assignments and the weekly skills labs are going to be pretty regularly, so hopefully you all can get ready, get used to that and get into the routine of doing it all. I'm getting a lot of emails. So is Dr. Volstead from this class. That's a good thing. Ask questions, give feedback. We like to hear what's not working, like dates due on things. We also like to hear what is working. But one request, please put ENGR100 in the subject line. You guys probably get 50 emails a day just from spam, and I don't consider you guys spam, and I'll know that immediately if you put ENGR100 in the subject line. It helps me make sure I don't skip over them and put them in the I'll read this later category. All right? I want to make sure I get this stuff. But I know a lot of you aren't doing this, so please try to do that. Okay, take out your clickers. Your first 1.5 points of the semester. Well, not the first. Well, is it? Yeah, it is the first. So remember, this room should be logged into channel 65, and the other room should be logged into 51. Not open. Oh, sorry. I have to practice, too. I forgot to push this button here. Okay, pull and close. And hopefully the people in the other classroom are doing this as well. Now it should be open. Let me just get rid of that. "300 students already have answered. You guys are fast. Now, there's something like 450 people in this room. I guess at least 400 of you have actually bought the clickers. 5 seconds. See who's waiting for the last minute. Okay. Wow. That's a bit surprising. This is the College of Mechanical Engineering, I guess. So, obviously, we have a pretty broad variety of people in this class. One thing I want to just draw your attention to, if you hadn't figured it out already, the people that are going to be on your team. Some of them are going to have a lot of engineering skills and background, or at least interests, and others might not. Okay? And then within this area, you're going to have lots of different disciplines in engineering. I've had several students come up to me and ask, gee, my roommate or my friend and I tried to fill out our CATME surveys exactly the same as each other so that we'd be on the same team. All right? Sorry. That might actually get you intentionally put on different teams. Okay? The idea behind this, and whenever you have questions or you want to complain about the class, first of all, come and do it. I'm happy to listen. Well, I'll listen. The idea here is we are trying to mimic as much as we can about what it's like to work in the real world. You're not going to get to choose who is on your team in the real world. What do you suppose your teams are going to be constructed on in the real world? Skills. I'm hearing that in multiple locations. All right? Now, you guys are brand new engineering students, and we don't really know what kind of skills you have just yet. But the survey tried to gauge what kinds of things you were interested in. Some of the questions did address, your hands-on, your skills and things like that. We're going to try to put together people who have, or we already did, we tried to put together people who have good building skills, good leadership skills, management skills, or organizational skills, things like that. And in many situations, these are not going to be your friends. If you if you're one of those persons who wanted to end up with your friend, hopefully it worked out for you, but that really wasn't something that we factored in. So just thought we'd mention it. As you can see from our survey that we just did, we have a lot of different perspectives coming into your team that you'll have to sort of embrace as best you can. Okay, so hey, it works. Okay. So today's topic, the hovercrafts. How do they work? What do we need to do for them? Now, in short, the hovercrafts are being built in your skills labs and a lot of extra time outside the skills lab. I don't want to mislead you on that. You'll be working on teams of 4 or 5 students. Please raise your hand if you've already logged in to see who your teammates are. Awesome. Wow, you guys didn't even have to be told that. Good. Okay, so you probably have an idea. Raise your hand if you've actually met more than one of your teammates. Okay, not so many. Okay? I recommend that you email each other to say, hey, we haven't met yet. Just send it out to all 4 of your teammates. Try to get a dialogue going. Try to get meeting with them immediately, as soon as possible. If you've already had your skills lab, that was probably easier said than for other people. If you haven't had your skills lab, you have to sort of get on the ball and do this on your own. So you'll be working with teams of 4 or 5. I have to say that some of the teams are going to get adjusted, so don't get too passionate about who you're working with just yet, because we have stragglers who are switching sections, and we might rearrange teams as we need, because we have found that some teams of 4 have already been knocked down to 3 because someone switched a section. That team of 3, we're either going to have to split up and send to other teams, or we're going to have to pull people off of other teams and make that 3-person team a 4-person team. So apologies for that. We should have all these adds and drops sorted out within a week. It all depends on how fast you guys add and drop. Okay. All right. The idea of the competition, and I'll essentially spend the rest of today talking about it, is to make a hovercraft that's going to be about yay big and goes about yay far, about 16 feet, turns around and comes back autonomously. By autonomously, we mean no human control, no remote control is permitted for this. So when you let go of that thing at the start line, you might as well walk out of the room and come back 2 or 3 minutes later, and hopefully it came back where you left it go. And hopefully it's not just sitting there because it never left, right? That'd be really bad. So autonomously is the key idea here. These Legos that we're going to be using in this class, I'll admit freely, can be controlled by your cell phone with Bluetooth. If you do that, you'll fail. Okay? That's cheating. We're going to be actually asking you to prove to us that you've disabled that feature in your NXT when you do the competition. So I know you slick people who have Mindstorm say, oh, yeah, I know you can control it with your cell phone. Not allowed. It's got to be autonomous. It'll be powered by batteries and fuel cells. In principle, you could perhaps power it through other mechanisms, steam engines and things like that. No internal combustion engines are allowed, like radio control car engines, the glow fuel and all that. Can't do that. We know that we're sort of painting you into a corner as to what you use for your energy source. This is one of the things that we decided to do partly for safety in this class. Otherwise, too many things blow up. Every team is likely to have a unique design. Last year, we had some teams that completely got their ideas from everybody else in the class, and then we had other teams who pretty much would work in a black shroud in the corner of the room because they didn't want anybody to see what they were doing. That's entirely up to you. If you have a great idea, maybe you want to protect it. Question? In principle, the question was, it says in the reading that you can reverse engineer previous designs. I'm not going to give you one. All right? We encourage that you come up with your own designs, but we know that somebody's fraternity or sorority probably has a collection of these things sitting on a shelf, and you can go and see what they did last year. Similarly, you can look at videos from other classes who have done it, and you can get ideas. This is a healthy thing, to see how other people solve the problem, but don't let it cripple your brainstorming process. I recommend that you don't do that until after your team has done your key brainstorming. Don't use it to drive your, because if you do it before you brainstorm and come up with your crazy ideas, it'll pollute the process. It'll bias you to see what other people have done. But it is allowed. Okay, optimizing and the speed and accuracy. Technically, you can get a really good grade just by getting it done, period. Speed isn't really the main thing here. We have records and everyone has bragging rights, or goes for bragging rights for doing it quickly. But in all honesty, accuracy. Getting to the end of the board without hitting the back wall and coming back before you fly off the end of the board and stopping. These are the accuracy things that we're going to really be rewarding in the way the point scheme is being done here. So we are hoping that you can be creative in the way that you do this. We're going to see a lot of hovercrafts that have similar features, but the way they're implemented will be infinitely different. Okay? You will not see 2 identical hovercrafts. Been doing this for years. We've never seen 2 identical hovercrafts. They're always going to be different. They'll oftentimes implement similar features, but it's up to you to decide if that was a good idea or a bad idea the last time you saw someone do it. You might be able to do it better. I trust that you will be able to do it better. So, questions that we oftentimes get are, what does making a hovercraft have to do with my kind of engineering? Fill in the blank here. Well, it's not about the hovercraft. So I can't really iterate this or emphasize this enough, okay? We're trying to get you guys to be familiar with the design process and everything that entails, ranging from the initial brainstorming phases to your final iterative testing, making revisions, and then communicating your results to the customer, which in this case are the instructors, okay? And hopefully you're going to have some fun along the way. Do you have to be in the same major? No, okay? That's sort of the point behind all of this. So I mentioned earlier, how do you find out who your hovercraft teammates are? Well, you can log into CatMe, It's going to tell you this. It's going to give you their email addresses. I recommend that you exchange phone numbers as well. If you only have someone's email, that just asks for problems when people are late for meetings and things like that. Get their cell phone. You can stay on top of it. That should be straightforward. I recommend that you know who they are very soon and meet with them, hopefully by the end of this week. Even if you're in the Monday sections, make an effort to try to meet this week if you can. Clicker question 2. This is a test of whether you read the syllabus and the team charter stuff, or the student, not the team charter, excuse me, the student contract. All right? And I talked about this in the other lecture. What is the budget cap for this year's team? Let me start this now. I'm going to learn this eventually. A little slower this time. In the first 10 seconds, we had like 350 for the last question. This is going to be an important number for you, obviously, because the money comes out of your pocket, for one. But we're going to be tracking your budgets, well, you are going to be tracking your budgets very carefully. All right, $300 per team. If you are a team of 5, you get to divide it among 5 people. If you're 4, it's among 4 people. So, all right. So that was the last clicker for today. If you want to put it away, you're welcome to. This whole lecture doesn't really have a whole lot of clickerable kinds of content. But as we go throughout the semester, some of the questions I ask will be related to doing a calculation in your head, asking you for your engineering judgment about whether something's going to break or whether it's going to work, those types of things. So we'll be using them for more substantive stuff as we go forward. Okay. A hovercraft is a device that essentially sits on a cushion of air, and it can be generated through any number of mechanisms. It's usually generated through a fan of some sort, though, that more or less blows straight down. Or if it doesn't blow straight down, it redirects it through ducting to blow underneath the vehicle. And this is what it generates it to, or it causes it to lift up off of the ground just a little bit. In our class, the hovercrafts are usually going to rise maybe 1/8 of an inch to 1/4 of an inch off the ground. If it were a large-scale commercial hovercraft, well, none of these are large-scale commercial hovercrafts, it can rise on the order of 6 inches to maybe a couple of feet off of the ground. It all depends on the nature of the application. If you're trying to make a hovercraft that goes over ocean waves or snow dunes or sand dunes, in those situations you might actually have a higher ride height. But it rides on a cushion of air, and we're going to talk about the nuances of this as we go forward. And next week we're going to talk about how you do calculations. Right? And that's a speeder bike from Star Wars. You're all like in an engineering class, so you have to deal with the geek humor. Right? Okay, but I did want to show you this. Who has actually been on a hovercraft? Anyone? I've never been on one. The U.S. doesn't have so many of them. Were any of them military? Any military veterans or active duty? Okay. The military in the U.S. is probably where you're going to see the most hovercraft action, and you can get a little bit of a feel for that in this video, hopefully in this video. All right, and make it go.
It's slowing down here. Now you're really gonna hear it.
It's on YouTube, some little kid commentating it for his father. But these are pretty large devices, right? They work very well. Our military uses it because it allows easy ways to land vehicles that can bring equipment, and you more or less aren't even going to get wet. Well, I'm sure in bad situations you'll get wet. But they can go right up onto the beach. Whether they're on water, on land, on snow, delicate surfaces underneath them, you can run over people with this thing. I won't say they won't feel it, but they really won't be hurt very much because it's essentially just a cushion of air. Okay? And when you want to stop on land, you just kill the lift and it flattens out, and the friction with the ground will keep it from sliding back into the ocean, more or less. Okay, so they can get pretty large. They're not only military. In the U.S., they're pretty popular as landing craft in our Navy, but in Europe and in other places, they use these for just in the place of ferries and devices, vehicles like channel crossings and things like that. They have benefits. They allow you to essentially go above the chop in the water so the ride quality can be better. But most applications are because of the ability to handle multiple types of surfaces, including water, obviously, which is a pretty good one. Now, the idea of this competition here is to make a hovercraft, except we're not going to be doing beach landings and invading anybody in Connecticut, but what we're going to be doing is this competition, all right? We have a 16-foot long board that we already have set up. You can see these in the classroom. And your hovercraft is going to start at one end. It'll be inside of a 2-foot, it'll be 4 feet wide. You'll be in a 2-foot zone that's called the start zone, right? And it has to fit completely in this start zone. Nothing can be hanging over the edge, either the front edge, the back edge, and nothing. Actually, it can only be 3 feet wide, all right? So you can't actually take up the full 4 feet of the playing surface. We found that 2 years ago, we allowed them to make it as wide as they want, so they just stuck wheels on either side and they just drove themselves down the walls, right? Yeah. Very fast, very creative, and they broke no rules, so we made a new rule. Right? We wanted it to be more challenging than that. So now you can't actually be, the dimensions will prevent you from reaching out and touching the sidewalls. And you have to go down to the other end of the board, sense when you've crossed into this 4-foot region on the opposite side using sensors and a microprocessor that you're going to program to read those sensors and then tell it to stop. And you will learn quickly that having a hovercraft stop is not the easiest thing in the world, all right? It's like being on ice skates and not knowing you can turn sideways, right? It's trying to stop when you're going in a straight line on a slippery surface or on a frictionless surface can be a bit challenging. You have to work out a mechanism by which you'll actually be able to do that. Whether you actually stop or not doesn't really matter. We want you to turn around before you hit this back wall. If you hit the back wall, there's going to be a penalty in the points, okay? And then it has to autonomously, all of this is autonomous, come back to the start, and notice there's no wall at the start, okay? If you go over the end, you'll lose points. If you go off the end, you'll lose your hovercraft probably. It'll probably break when it hits the floor. So actually, it's hard to get your hovercraft to go off the end of the board. Anyone guess why? No, there's no wall over here. What typically keeps the hovercraft from going off the end? Oh, a lot of hands over here. It loses the plume of air underneath it that keeps it up. Anybody else have a different answer? All right, means you agree. Okay, there's no surface for the air to push against. Okay, important concept behind hovercrafts. It is not that it rides on a jet of air, right? It's because there's something that air is pushing against, and it causes that air to build up pressure, and it rides on a cushion of air pressure. We'll get into this much more next class. But it's different than having an airplane flying vertically, right? There, it actually has a jet of air that is essentially propelling behind it, and it's a momentum thing where you allow yourself to have your thrust of your vehicle oppose the momentum of the air that's being pushed in the backwards direction that effectively pushes you in the forward direction. If you've ever seen a Harrier aircraft, these are jets that allow you to do just this. Those jets point straight down. Instead of pointing out the back of the airplane, they point straight down, they pivot, and they allow the aircraft to just rise straight up, right off the runway. They don't actually need a runway. They work better with a runway, but they can rise straight up using a jet. Hovercrafts cannot do this. They don't generate anywhere near enough thrust out of the fans. However, they generate enough if it's pushing against something and to cause a reaction and a pressure buildup. So we'll be looking at this later on. So, get back to my initial question. Why doesn't it fly off the end of the board? Because there's nothing. Once the front edge of this extends and peaks over the edge of that table, it no longer has anything to push on, and the hovercraft just sinks down and lands on the surface. Okay? If you're going fast enough, it might skid off the end, but usually it doesn't. Usually they're not going that fast. Because if they're going that fast, they weren't going to slow down fast enough in the first place. Okay, so all of these rules are going to be explained to you throughout the semester. A good place to start is on the website under the lecture notes for both today and as well as last week. We have the Hovercraft Specifications, and I recommend you take a look at it. These are sort of the rules. I'll be filling in details on the rules as we go forward throughout the semester, but I'll be highlighting them here today. Hopefully I won't forget anything. But there are no weight restrictions. You have size restrictions of 2 feet by 3 feet. The 3 feet is because I don't want you touching the sidewalls at the start line. And the 2 feet is because you have to be able to fit in the starting area, which is only 2 feet deep. Okay? And questions will be asked later. we're going to allow things that called stabilizers. And do the stabilizers get included in the dimensions? The answer is yes. Okay? On the last day of the semester, last year, we had lots of teams decide to change their stabilizers, and it made them too big. All right? And they got a rude awakening when they came up to the competition and were told that they were too big and they couldn't do it. They had to take those stabilizers off. Well, they went and redesigned it, but you don't want to be surprised like that, so I'm going to try to draw attention to it now. It's no larger than 2 by 3 feet in strict terms. Okay? Your lift fans have to be battery powered. No internal combustion engines, I mentioned that. All fans have to have protective fan guards. Our #1 cause of injuries in this class, even when we tell them they have to have fan guards, is people stick their fingers in the fans by mistake. It's very easy to do. These fans, they run extremely high speeds. They will probably take the tip of your finger off if you're not careful. We had people get their fingernails cleaved into several times. They're powerful. They spin very, very fast, and if you're not careful, you can accidentally, I mean, we have people, it happens even more often, they do have the fan guards in front of it, and they have loose objects like ball bearings or whatever that they're using as counterweights, and the ball bearing will roll into the fan. It shreds the fan. All the blades of the fan will get taken completely off. They turn that fast. So use fan guards. You can imagine if a little 1/4-inch ball bearing is going to rip all the blades off the fan, imagine what your finger would experience if you were to stick it there. So please be safe as much as possible. Finally, although the lift fans can be you don't have to, but you'd be kind of throwing away a good approach if you didn't want to use batteries. But the navigation, the mechanisms by which it moves horizontally, the thrust, call it, or the propulsion, another way to look at it, has to be powered or controlled by the fuel cell. Okay? This is a nuance to the rules that we are throwing in there to make it challenging for you. Because if we allowed you to do that with batteries and battery-powered fans, it'd be real easy. That's the kind of thing we'd give to grade school kids. It's that easy. In this class, you have to figure out how to do it with the fuel cell, which is this little dinky object that weighs next to nothing, runs on hydrogen and oxygen, air, and it will generate up to 3 volts, usually only about 1.5 to 2 volts, and a maximum of a couple of hundred milliamps. Okay? The equivalent is, think of a AAA battery. All right? That's how much, that's dangerous for me to make that comparison, but that's the kind of level of energy that you have. You have to make very efficient and creative use of the energy that this fuel cell can generate, because that's what you have to use to do your propulsion. There's some fine print to that rule that I'll get to probably in a couple of lectures. So, some things that you're going to have to do along the way. Your hovercraft is going to have to be able to levitate or float for 3 minutes. Your final competition might just take you 15 seconds, all right, if you're fast. But there are some checkpoints along the way where you have to demonstrate that the thing can hover in place and not drift off to the side for a total of 3 minutes. So you have to have enough energy to last for 3 minutes. Your batteries have to be able to last for 3 minutes. Okay? Your hovercraft has to be controlled by a Lego NXT microcontroller. That's what this thing is here. There are other ways to do it, but in this class we didn't want to have to deal with all of the other ways, and then we'd have to show you how to use all the other approaches, microprocessors, basic stamps, things like that, atmels. The list is very, very long. We decided to use these because they're easy, frankly. We're going to be programming them using LabVIEW in this class. And again, as I said, it has to autonomously navigate the course, and that navigation or propulsion, everything other than the lift, has to be controlled or powered by the fuel cell. And again, it's out and back, 16-foot-long course. Okay. Your materials, all told, can't be more than $300 per team. And that includes a rental kit that you don't have to rent, but the alternative is paying about $350 to go out and buy it on your own. 99.9% of the people rent the kit. It'll include the fuel cell. That's like $170 right there. The Lego NXT, it's light sensors, touch sensors, ultrasonic distance sensor. That right there is a kit that's probably about $250 to $300 by itself. And then we'll give you some relays and prototyping board and wires to help make the process work well. All that will be $50 that you have to include as part of your $300 budget. Okay? Once your team gets together, you should start developing a plan for picking up your kit, paying for your kit first, actually, picking up your kit. Do it as a team. So once your team gets together, maybe this week, that should be on one of the first things you talk about. How are we going to pay for this? And it's usually, all right, it's $50. There's 4 of us. Each of us pay up $12.50. I'll go over there tomorrow, and I'll pay the cashier, and then we can come back and pick up the kit in the EDL. Just to let you know, the kits are not actually ready just yet. Well, this is from last year, 2 weeks. We might be ready next week. We're pretty close to being ready with the kits. Once your team has paid for it, you can come and pick it up. But you'll do this as a team. It's the same exact process as you used to pay for your textbook, all right? Except you're going to do it as a team. Was there a question back there? No, please give the receipts to either to me, like after class, or to the people on staff in the EDL. I've had about 3 or 4 people see me on campus and try to give it to me. I've declined it because if I get them in that case, I'm really likely to lose them, especially if I'm not like walking to my office at that time. So after class, before class, or in your skills labs, or just go over to the EDL and hand it in there. That way, if I lose it, your team's not out $50. Another question? What is the EDL? The EDL is the Engineering Design Lab. It's where you do your skills labs. Sorry, it's our lingo. Any other questions about getting this paid for? I think I saw, guess not. Okay. Okay, so this project is going to be a bit involved. You have a lot of things to do in this class, but the majority of the portion of your grade, the majority of your activity is going to be done with your teammates. So you want to try to get off to a good start, get into a good working relationship, good study skills as a team, because your whole team will be affected by it. Of all the things we have to do in this class, ranging from your reading projects, your skills labs that are done on an individual basis, you're going to have team journals, 5 different design checkpoints for your hovercraft project, 2 oral presentations, 2 written reports, and your final competition. All of those are done as a team. Okay, so obviously you have to get to work together with your team and get into good habits working as your team, because your grade depends on everybody else carrying their weight, and they likewise are depending on you carrying your weight. Okay, so a brief overview of hovercraft. So before that, was there a question? Does every person need a team journal? No, only the team. It's done as a team. Okay, so the things that you do as a team, we'll ask you to hand in as a team. You're not going to make 4 photocopies and hand them in. You'll just hand them to us as a team. And as a result of that, those things we tend not to be able to hand in online very easily. We're going to have you hand them in person, because the online ones are always attached to one person's account. All right. Okay, so hovercrafts. It doesn't sound like too many people have actually seen them. They haven't been around for all that long, strangely enough, because the concepts that go into how they work are relatively straightforward. The concepts have been understood for much longer than we've actually had hovercrafts, before somebody had that light bulb go off in their head and say, hey, I can do this and I can make this. Right? The credit is typically given to Christopher Cockrell, who we say invented the idea, but he certainly developed our modern concept of using lift skirts and downward projecting thrust and things like that. Only in the late 1950s did we first have our hovercrafts. But that said, we have to give credit to a group of Russians who were able to develop important concepts that predated World War II. So they predated Cockrell by some 30 years in some cases, of having structures or vehicles, I guess I'll say, that operated on similar principles of building up a cushion, a high-pressure cushion of air underneath the vehicle that allowed them to move very, very fast. They're able to get these things to go something like, I think they said in the report, something close to like 70 kilometers per hour, which is pretty good back then. This, excuse me, this one managed to cross the English Channel back in the 1950s. Nowadays, we do that, you pay $15 or $30 or whatever it costs. You can get a commercial trip on a hovercraft across the English Channel. So, important thing to know is that the concept involves a propeller pointing straight down, which might sound an awful lot like a helicopter. Okay? But this goes to that distinction I mentioned a little while ago. The thrust coming off of the blades of that propeller are not enough to lift the vehicle in free air by itself. It needs the surface of the ground underneath it to push against in order to actually make it happen. So the benefit is you don't need anywhere near the power of a helicopter engine in order to make this happen. It tends to be much less than half of the power of a typical helicopter engine for a same size or same mass vehicle. Typical speed or the current speeds for these things are about 85 miles an hour. That's kind of lame by modern standards. Part of the problem of being able to do this is you need to have very smooth places to do this with. And hovercrafts, the height above the ground, you'll find in your calculations that you start doing in your skills lab next week, the height above the ground makes a huge difference to how much lift you have and how much friction it has. And If you have any bumps in the ground or any wind or anything like that that could get it knocked off kilter, even slightly tilted, your tail's going to start dragging, and suddenly you're no longer going as fast as you were, or you might actually damage the vehicle. So getting really fast really requires that you have a very smooth track. Okay? But fortunately, you can get up to 30, 40, 50 miles an hour without too much trouble. Get above that, what you're hovering over makes a big difference. Practical terms, it means that we can't really get going to obscene velocities the way we can with the bullet trains and magnetic levitation and things like that. Okay. Let's see. Largest civilian one is pretty large. 60 cars. It's a ferry. It can hold up to 418 people. I couldn't find any pictures of it, though. This is one of the military ones shown with, it looks like 9 Humvees in it. So they're pretty good size. Okay. Another one. This one's more interesting. Some creative engineers working out of their garage, or wherever, his backyard. All right, will it start automatically? There we go.
The Jesus pen.
The audio's not so good. He's pointing to what he calls the Jesus bolt. If it breaks, you get to meet Jesus.
Rudy Heeman is an inventive New Zealand mechanic who's put together...
It's not hard to make a hovercraft. A leaf blower and a plank of plywood is all you need to make a hovercraft.
When it hits 70 kilometers an hour, it stops hovering and starts flying.
Now, it's not flying because the fans are pushing down really hard. It's flying because it's got wings. The hovercraft got it above the water surface. The backwards pointing fan or propeller blades get it to go forward. Once it gets going forward fast enough, it gets moving pretty quickly. He's trying to sell these things for about $13,000 US. I really want one. I mean, it's pretty cool. Do you have to have a pilot's license? I have no idea. My guess is no. This probably falls in the category of an ultralight more than anything else. I don't know. Has he ever sold one? No, I don't know if he sold one. There are other companies. This guy's an Aussie. There are companies in the US. There's probably like a guy in his garage kind of company who are if you go on YouTube and you search for these, like flying hovercrafts or whatever, you'll see all sorts of them, and you could probably find their websites on those YouTube pages. So you can do some interesting stuff. If you guys can get your hovercraft to fly to the other end of the competition board and come back, I'll be impressed. Unfortunately, it won't affect your grade. It probably would affect it, but no one's ever come close. Getting it to turn around would be the hard part. So, hovercrafts work, at least in this class, on 2 principles that you have to kind of separate from each other. And we're forcing you to because you have different power sources for them. You have the lift and you have the propulsion. The lift is the stuff that is the propellers that point downwards. These fans are sucking air from above and pushing it down below. Underneath, on the sides, we have these, commercial ones usually have a flexible, usually rubber or something like that, skirt that allows pressure to build up underneath it. And you can float on that pressure. And then these propellers that point forwards and backwards, they can actually rotate to get it to steer in different directions. The lift part that you're getting is important because without this lift, it's just going to drag on the ground. You need to get enough lift to get it up off the ground. In order to do that, you need to build up pressure underneath it. And for that, we have what we call the Plenum Chamber underneath it. So your hovercraft is going to have a variety of different components that we'll go through quickly right here at the end of class. So the lifting fans, they don't have to point down, but if they don't actually point down, you're going to want some sort of ducting to direct that air underneath the hovercraft. Okay? If it hovers too high, if your fans are too powerful, if it hovers too high, it gets unstable. It tends to bump its edges. It tends to be difficult to control. You're going to want to find a happy medium. If you wanted, you could get a really powerful fan that got it to rise a good inch off the ground without too much trouble. But being able to control that becomes a little bit more difficult. Too little lift, and you'll actually be dragging the edge of your hovercraft, and you get disqualified. It's not hovering. Okay? So you want to make sure you have enough. Okay. The deck materials, this is the big surface, that's pretty important. The top side of the deck, it's important because it's holding your stuff there. The bottom side of the deck is usually shaped in a way to allow it to build up pressure better. I'll talk about that in a second here. Materials are usually lightweight. If they're not lightweight, then you're not trying very hard. balsa wood, foam core, styrofoam sheets that you can get at Home Depot for like $5. I mean, something you find in the dumpster or whatever. It doesn't have to be fancy. Plywood's probably going to be too heavy. In fact, if you use a 2-inch thick piece of styrofoam, that probably is going to be heavier than you need. You can make it work, but it's probably going to be heavier than you need. So you're going to have to use your judgment calls in picking an appropriate material to make this thing out of. Okay? The shape, that's entirely up to you. Rectangular and round will be easier to do the calculations that we'll show you in a couple of weeks, but you can make it any shape you want. Okay? The shape of the hovercraft usually isn't terribly important, to be honest with you. Much more important is the shape of the bottom surface of the hovercraft. Okay? We have all sorts of tools available for you to borrow and work with in the EDL. So you can borrow things like foam cutters, hot wire. They basically melt lines through the foam. It's much easier than using a saw, much cleaner than using a saw. When you use a saw, you get little styrofoam beads and pellets everywhere. You're going to be plucking them out of your ears and nose for like a week. It's ridiculous. So I recommend using the hot wire cutters, not a saw. The shape of the bottom of the surface of the deck is fairly critical. What you want is essentially a cavity that allows the air that's being pushed downwards from your fan to enter this plenum chamber and essentially not be able to escape as fast as it might otherwise. You want it to get restricted so that the pressure can build up a little bit. Pressure builds up to a certain point where it then starts scooting out. The air starts squeezing out, spilling out underneath the bottom edge. But there's usually a happy balance. It builds up a certain amount of pressure, and then when the pressure is high enough, it lifts the whole hovercraft up. That's the whole point, right? When the hovercraft lifts up, you create a window. Then suddenly the air squeezes out. It's a happy balance. You're continuously adding more air while the air is squeezing out the sides, and in between those 2 points, you're building up this pressure cushion that it floats on. That's the essentials of how it works. We'll talk about this in more depth next Monday. Okay. The skirt around the plenum, which means these side edges, has to be rigid here. All of those videos I just showed you had flexible skirt plenums. Right? We're not using them here because those hovercrafts, it was okay if they dragged a little bit on the ground. In this class, we don't want you touching the ground at all. It's a little bit more challenging, but making a rigid plenum is not hard at all. The easiest thing to visualize is think of a Frisbee, right? It's got a hollow cavity underneath. If you were to put that on the table, stick a fan in the top and blow downwards, you're effectively creating a plenum chamber. This is the cavity on the bottom of a Frisbee. Okay? We actually had people make them out of Frisbees last year, but the plastic is not terribly lightweight. Right? You can make it work, though, if you have a powerful fan. So the skirt should be rigid. No part of your hovercraft can touch the ground. You're going to be experiencing difficulties with actually balancing everything, but you should be able to do it. That's one of the challenges of this class. Stabilizers are going to be permitted. This essentially means you can drag something small and lightweight behind you to keep the rear end and back of the front end. Otherwise, these things rotate, and they'll start spinning, and they're very difficult to figure out where the end is and which way is forward and which way is backwards. Because remember, you have to know where you're going and where to go back to. So some notion of forwards and reverse is important. These stabilizers, classical things will just drag a string behind them. Or they'll put a training wheel, like on a bike, they'll put a training wheel hanging off the front, but it's on a hinge, so it can't actually hold up any weight of the hovercraft. If you turn the fans off, the hinge that training wheel is on will just it'll just bend, the hinge will rotate, and it will just settle down onto the ground. We'll talk more about the details of this later on, but the concept behind these stabilizers is to keep the rear end and back of the front end, like an airplane. The tail of an airplane doesn't help it stay in the air. It just keeps the back end in front of the front end. Question? Exactly, yes. So these stabilizers, if they're hanging off the sides, you don't have to hang, you can make them underneath you too. If they're hanging off the sides, the stabilizers get included in the maximum dimensions of your hovercraft, the 2 feet by 3 feet. Another question in the back? The maximum dimensions apply at all times, before and while it's moving. So in other words, to cut to the punchline, you're not allowed to unfold and grow midway through the competition, midway through the run. Clever questions, but if you read the rules, they actually are phrased carefully to deal with these types of things. Okay, let me just see where we are here. I will pick this up at the beginning of the next class. Are there any questions before you take off? One up here front. Hold on, hold on. Over here. Where do you get the fan? We'll talk about that ad nauseum in the next couple. You can use as many as you want, but they can't be more than a total of a half a pound. Okay, thank you, everybody. We'll see you next Monday.